Hello all, welcome to my channel, Master Computer Science subject. Today in this video, we are going to discuss about a simple bootstrap loader. So what is a bootstrap loader? It is a special type of absolute loader. We know what is absolute loader. It just loads a program into the memory whenever it is required for execution. Okay, what is bootstrap loader? It loads the very first program what is required by the computer and begins the execution. So what is the first program to be executed? It is nothing but the operating system. So Bootstrap Loader is the absolute loader which loads the operating system into the memory for execution as soon as the power of the system is on. Now we are going to understand a very simple Bootstrap Loader with respect to SIC architecture. Okay. Bootstrap Loader itself is a program. That program is available from the starting address 0. And this program loads the operating system into the address 80. Okay, just for the sake of clarity or just for an example, I'm just giving you how the OS program looks. OS program looks like this, continuously like a sequence of object codes. And this OS program, which is available as object codes, does not have the header record, text record and the end record. It is having only the sequence of object code. But while loading the program, there is a problem. What is the problem? When the loader reads this object codes, it reads each digit of the object code as a character. So when it reads as a character and when it tries to load, every character occupies 1 byte in fact instead of half byte. Now every object code is a hexadecimal digit and we know that every hexadecimal digit needs only half a byte memory. But when the loader reads this hexadecimal digits, it reads it as a character and while storing it will occupy 1 byte. So this problem is to be tackled and this 1 byte must be converted into half byte and must be loaded into the memory for execution. So this is the problem while loading the program. Okay, now just I'll show you the Bootstrap Loader program and we will see the overview of the program. Later we see an example. Boot is the name of the program. As I said earlier, this is completely the loader program and this loader program is available in the memory starting from the address 0. That is why it is given the Bootstrap Loader is available in the address 0 and this loader program loads the operating system from the address 80. Just we see the program. Next instruction is clear A. It means it is clearing the accumulator. Next instruction is loading the register X with the decimal value 128. This is in fact decimal value. When you convert this decimal value to hexadecimal, it is nothing but 80H. So what does it mean? The register X is loaded with the value 80H, the hexadecimal value, which is the starting address of the operating system, from where the operating system is to be loaded. Then after this, it is jumping to the subroutine getC. This is completely the subroutine getC. Let us see getC little later. Now we see just the main program now. After jumping to the getC, it just reads a character and performs some internal operation to convert that 1 byte character into half a byte. Then it performs this operation. What is this operation? Register move operation. Whatever the character is read, it is available in accumulator right now. That content is moved to S. So the content of accumulator is moved to S register. Then this S register is shifted left 4 times. Shift L, S, 4 means whatever the content is available, it is shifted left for the 4 times. After performing these two operations, it is once again jumping to the subroutine getC. So there are 2 times right? It is jumping to the subroutine getC. It means it is reading a character. Once from the getC, the control is written here. What is the operation to be performed? It add the contents of S and A, and the added value is available in the accumulator itself, right? After this operation, the value of X, whatever is there in that address, the character from accumulator is moved. S content is added with A and the result is available in accumulator. Now the content of accumulator is moved to the register value, whatever is there in the X, to that address. It means the very first character is moved to the address 80. Then this X register is incremented so that it is pointing to the next address where the next character is to be loaded. Likewise, the object code of the OS program is converted. Some internal conversion is happening to convert that 1 byte into half byte. After that, it starts being loaded. So these two instructions are in fact taking care of the loading part. Then again, loop. It is going to read another character. Then alternatively, it reads two characters, performs some operation, loads into that. Again, it reads alternatively two characters. Likewise, it continues. Now, just we have a look of the getC subroutine. In the getC subroutine, the very first instruction is it is testing the input device. So what is input? Input device address is given as F1. It is just waiting for the input device. So how long it waits? Some condition code is being checked here. As long as it is equal, it is being waiting for this. Once it becomes unequal, it is ready to receive the object codes from the input device. So it is reading the input. Then the input, whatever is being read, is compared with the value 4. If it is equal to 4, jump to the starting address from where the OS is to be loaded. Otherwise, it is being compared with the hash 48. If it is less than, go and read another character. If it is not less than, subtract this hash 48. Then again compare the value with 10. If it is less than 10, return to the main program to read the another character. That is the purpose of this return statement. If it is not less than 10, it means if it is greater than 10, subtract 7. Likewise, some internal operation is being performed. This internal operation now we see with an example. Let's see the example for the Bootstrap loader. Here I have taken one object code. Each digit in the object code is half byte, so the length of this entire object code is 3 bytes. But already we discussed the problem while loading. While loading, every digit of this object code is read as a character by the loader. So the corresponding ASCII value is 31. If 1 is understood as character by the loader. For 7, the ASCII value is 37, correspondingly for the other digits. Now, if these ASCII values are stored, it requires 6 bytes. In fact, then the loader program will occupy the double the size of the memory what it actually requires. So we have to trim the size of the memory. This loader program takes care of that also. So let me explain this with an example. Once again, we go through the program at the last. Okay. In an object code, every 2 characters are alternatively read and combined to become a single byte. So now while loading, the loader reads 1, it performs some operation, then immediately it reads 7, it combines with 1 and gets a value. So this is how the loading operation is continuing. Okay. Now it is reading the first hexadecimal digit 1, but it is stored as or treated as a character whose ASCII value is 31. Now this is being compared with 4. 4 is the decimal value. In SIC architecture, this 4 refers to the end of file. It means once the complete OS program itself is consumed by the loader, it reaches the end of file. that time it should jump to the address, the starting address, which is 80, to begin the execution. So now this condition is false in this case. Next, this 31 is being compared with the decimal value 48. If you convert this decimal value into hexadecimal value, the value is 30. In fact, the 30 hexadecimal value is compared with the 31 ASCII value. Both are in hexadecimal format now. You are comparing. If this value is greater than this value, if the value in the object code is greater than the 48, we need to perform the subtraction. Subtract 48 from this 31. It means subtract 30 from 31. If you subtract that, we will be getting 1. That 1 is available in binary format in accumulator. Now, this one is being once again compared with 10 in the sense whether it is less than 10 or it is greater than 10. If it is less than 10, return to the main program. We know that in the Bootstrap Loader program, this is the main program and this is the getC, right? So now get character is reading the character. Once a value is available in the accumulator, it will return to the main program. And in the main program also, we know there are two jump to subroutines. So the first jump to subroutine getC is executed. Now these two instructions will be executed. Once again, the main program jump to the subroutine getC to read the character for the second time. Okay, now let's continue with the example. Now this is a value available in accumulator. It is being compared with a 10. Since the value is less than 10, it is being written to the main routine. So now accumulator contains a value 0000001. Now from accumulator, this value is moved to S register. S register contains the same value whatever is in A. Now S register is shifted left for 4 times. If it is shifted left for the 4 times, 0001 and the remaining 4 empty places is filled with a 0. So now this is the content of S register. Once this operation is done, main program once again jumps to the subroutine getC to read the next character. So what is the next character here? The next character is 7. Now again same comparison, all these operations will happen. The ASCII value for 7 is 37. Now we have not reached the end of the file, so this condition fails here. Now this value is compared with decimal value 48. It means it is compared with hexadecimal value 30. Now the object code value is greater than this. If it is so, you have to subtract hash 48. If you subtract hash 48, it means 37 minus 30 you have to perform. 37 ASCII value is in hexadecimal. The hexadecimal equivalent of 48 is also 30. 37 minus 30 if you perform, the value is 7. So 7 means what is available in accumulator now? 0000111. This is a value available in accumulator. This is in fact a 7. This is a binary equivalent of 7. Now this is being compared with the 10. It means whether this result, whatever is there in accumulator, is less than 10. Yes, it is less than 10. So return to the main program. If it is written to the main program, what happens now? Now the accumulator contains a value 0000111. In the main program, it is told that the content of S and A must be added. If the content of S and A is added, what will happen? So let me write what is in S. Let me write what it is A also. A contains 7. If we add these two, the binary information what we receive is 0001011. Now if you find the corresponding hexadecimal equivalent, this is equal to 1, this is equal to 7. This is how we are reducing the 2 bytes of memory space what it is occupying into 1 byte of space. Okay. Remember that every pair of hexadecimal digits is being read. The problem is the loader is reading it as a character. If it is reading it as a character, it allocates 1 byte of space or it requires 1 byte of space. But it is in fact hexadecimal digit which requires only the half byte, that is 4 bits. So to convert into half byte, we are performing all these operations. We are comparing with end of file, then we are comparing with whether it is equal to the hexadecimal value 30, then we are comparing with whether it is equal to the value less than 10. Then likewise we are performing. Then when the first character, when it is read, it is loaded into accumulator. From the accumulator the data is moved to S. Then again we are shifting left the content of S 4 times. Then the main program is calling the subprogram to read the another character. When the another character is read and the same conditions are being checked, this is what available in accumulator. S and A are added and this is the result. Okay. Now just for the sake of clarity, I will repeat the same thing for the last 2 digits. 2D. It is in fact occupying 2 bytes. Now the memory space should be trimmed into 1 byte. Right? So this 32 is the ASCII equivalent. For D, 44 is the ASCII equivalent. Now first we are checking whether the getC is reading this character first. When it reads, it has not reached the end of file. So this condition fails. Then this value is being compared with hash 48, which means the hexadecimal value 30. This value is greater than hash 48. So subtraction will happen. When the subtraction happens, accumulator contains 2. 32 minus 30 is 2. You can perform this with a scientific calculator. I will write it in the binary form 0, 0, 1, 0. So this is 2. Then this value is being compared with hash value 10. I mean the decimal value 10. Where it is being compared with the 10, this is less than 10. If it is less than 10, return to the main program. So now this is the value of accumulator. Accumulator contains 0, 0, 0, 0, 0, 0, 1, 0. Now this is being moved to S. S also contains the same value. Now S is shifted 4 times. If S is shifted 4 times, S contains 0, 0, 1, 0 and these 4 empty spaces will be filled with 0. Now this is the value of S. Once this operation is done, it is going to read the next character. Now this is D. Its ASCII value is 44. Now this has not reached the end of the file and this is being compared with the hash 48. Absolutely this is greater than 48. You can perform the subtraction. I'm leaving it to you. You can have to do the subtraction. Do the subtraction. When you are doing the subtraction, take care that you have to do the hexadecimal subtraction. Hexadecimal subtraction. Right? After performing the subtraction, when you compare the value with hash 18, certainly it is greater than 10. I mean the difference is it is greater than 10. Once the difference is greater than 10, further you have to subtract a 7. Then only you are able to extract the other digits of hexadecimal like A, B, C, D, E, F. So now the result is greater than hash 10. So further we are going for the subtraction of 7. When you perform the subtraction 7, now here you will be in fact obtaining the value D. D means 10, 11, 12, it is 13. 13 means its binary information is 0, 0, 0, 0, 1, 1, 0, 1. This is the binary information finally available in accumulator. Now accumulator contains 0 0 0 0 1 1 0 1. Now this S and A is to be added. When S and A is to be added, the result what is available is 0 0 1 0 1 1 0 1, which is 2. When you convert this 13 into hexadecimal digit, you will be obtaining 2D. Now 2D put together occupies 1 byte, whereas earlier it was occupying 2 bytes. You perform this calculations, then it is easy for you to understand the code. So this is a code. After performing the example, one example on your own, you please go through the code. It is easy to understand. Any doubts if you have, please put it on the comment section. I'm ready to clarify your doubt. Thank you.